So, all right, without further ado, here is Garte, everybody.
Thank you. Before I start, I just want to get a little survey. How many people here have PhDs in biochemistry? Great, so I can say anything I want. That's perfect. Okay, very good. Okay. God does not exist. There's no such thing as God. It's impossible. It could not be a God. That's what I was brought up to believe. I came from a militantly atheistic family, going back 3 generations. And that's what I thought for most of my early life, in fact, all of my early life. And yet here I am, speaking to an apologetics conference as a devout Christian. And how did I get from that starting place to where I am now is a very long story, and I discuss it in this book. I think some of it, I think it's available outside. It's also available everywhere else. And I'm not going to talk about that very much today, except for one part of it, which is that science, particularly the science that I was doing and studying, was a large part of my starting on my faith journey. And I'm going to talk today about one part of that, which is what I know best, which is the biochemistry of life and how it relates to the origin of life. Now, what's interesting is that sometimes I call myself a biologist, sometimes I call myself a chemist. That's the great thing about biochemistry. You can do either one, or pretend to. And sometimes I have often found, in just my own anecdotal experience, that biologists are really strongly atheistic. And I thought that was just my own imagination, but in fact, this slide shows that among the fellows of the Royal Society, 68% of physicists consider themselves as atheists, whereas 89% of biologists do. It's a real difference. And that seems strange on first glance because, you know, we heard from Luke Barnes yesterday that there's so much design in nature and in you know, the universe and galaxies, but especially in life. And in fact, here's some photos of examples of design, the beautiful flowers, the incredible speed of a cheetah, various fish, one bird here. I didn't include a hummingbird, but that's Luke's specialty, so I'll leave that. And of course, the most important example of design are us, human beings. And here I have the best example of human design. This happens to be my wife. And since she's not here, I have no problem showing this. Otherwise, when I've shown it when she was there, she got upset at me. But anyway. Even Daniel Dennett, the very famous atheist, says biology, the biosphere, is utterly saturated with design. Richard Dawkins, you heard this, I think, from Luke, has talked about design in life, design in biology. And of course, what he says is it's the appearance of design. So we'll get into that. So the question is, if there is so much design in life, if it's so obvious and so universal, how could it be that biologists are so ungodly? Why don't they make the connection? There's so much design. And the answer is very simple. Evolution. And of course, it was also Dawkins who said that evolution allowed atheists to be intellectually fulfilled or something like that. Because it allows, according to him, it allows people to become atheists because with evolution they have an explanation for all these things in life that seem to be metaphysical before evolution. So what we have now is a question about what is the source of all this design in biology? And as I said, the first one up there is evolution, and that's what almost all biologists will tell you, and many other people. And what we see as design is simply the result of natural selection, with no purpose other than survival and reproduction. The elimination of purpose from biology is a key tenet in modern biological philosophy. Of course, there's also a view, and of course you all know about intelligent design, that these complex designs could not have resulted from blind random chance and were deliberately designed by an unknown intelligent agent. And very similar to that, but going a little further, is the idea of a divine being. Life's design requires far more than mere intelligence. This is my own idea. I haven't found a quote for it. They are indicative of a divine agent, God, who used evolution as one of his tools for creation to some extent. So let's go into this in a little bit more detail. Now, you've already seen this. Luke Barnes presented it. It's something that almost all scientists who are Christians, don't like. The universe that we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. Very pleasant quote. So we're left with this idea that life has design without a designer. And here's another quote from Dawkins. And here's where he says that it's an illusion of deliberate design. It looks like design, but that's an illusion. And some people go further and look at some of the specifics of life. For example, DNA and the genetic code. In 2017, Stephen Woodford, Rationality Rules, made a video in which he said that DNA code is not a code because it isn't interpreted by anything. It's a set of rules and instructions that follow the physical laws of nature. That sounds very nice, but I have to caution you that Stephen Woodford is not a scientist, and he's certainly not a biologist. And in that video, he makes a lot of basic scientific errors. But I'll get back to this a little later. So now let's ask this really important question. Is it true that evolution is really atheistic? If you hold to evolution, does that mean you are an atheist? Actually, the answer is no. Evolution has nothing to do with any kind of metaphysical or philosophical or spiritual issue. It's a biological scientific theory, and it only relates to the biology that we know, starting with the last universal common ancestor, Luca, and I believe ending just before the origin of humanity. Evolution deals with the diversity of life, and this is very important, but cannot contribute to the origin of life. And that is universally recognized from Darwin to Dawkins and everyone else. Darwin did not talk about the origin of life. He had a brief paragraph speculating what might have happened, but of course he had no idea, and we still have no idea. You've heard this from some of the great work that James Tour has done, that this idea that we're close to understanding the origin of life is simply untrue. And I also like to say that evolution not only doesn't explain the origin of life, it really doesn't say very much about us. There are ideas, stories that float around about consciousness, creativity, love, everything that makes us human. But those are just stories. There's no evidence behind any of them, and there's no mechanism, there's no scientific mechanism by which biological evolution can produce somebody who composed Beethoven's Fifth Symphony. It just doesn't make sense. Well, let's look at evolution a little more carefully, and we'll see why this is a real problem. When you ask almost everybody, and it's very common, what is evolution all about? They'll tell you it's based on two things. The first is genetic variation, so mutations in the DNA, changes in the DNA, and that genetic variation is translated into phenotypic variation, and that the phenotype just means everything about an organism. Okay, so your height is your phenotype, so are all the chemical reactions that go on in your body. And the other thing it depends on is natural selection, which is how good is that phenotype in helping you survive and helping your offspring survive. And speaking of offspring, there's actually a third critical component of evolution that is almost never mentioned, but it's just as important as these two. And that is accurate inheritance of the phenotype to future generations. And this is what I'm going to be focusing quite a bit on. If you have a mutation that improves your fitness, okay, let's say that I get a mutation that makes me incredibly strong and brilliant and everything else, that's nice for me, but if I don't pass it on to my offspring, there's no natural selection. Because natural selection happens over time. Time being many generations. And in fact, Darwin said this. And look at the underlined lines. And from the strong principle of inheritance. Now, of course, Darwin had no idea what that was, but he knew there was a strong principle of inheritance. These will tend to produce offspring similarly characterized. In other words, accurate replication, accurate self-replication. Now that strong inheritance, well, I just said that, requires accurate self-replication. Now what do I mean by self-replication? Well, let's take a look first at this illustration of the reason that you need accurate inheritance in order to get evolution. Let's say we have a population of giraffes on the left of different heights. The taller ones, especially if the environment becomes difficult to find food, the taller ones will survive better than the shorter ones, and after many generations, the shorter ones will die out, the taller ones will be better able to adapt and to find food, and they will become dominant in the population. That is natural selection at work, very simply. But that assumes that tall giraffe, I keep calling them elephants, I don't know why. That very tall giraffe passes on its traits, its phenotypic traits, which come from some genetic event, to all of its offspring. And those offspring pass it on too. And if you don't have that, if you have inaccurate genetic inheritance, you get tall giraffes, and you also get short giraffes, the original short giraffes, because the tall giraffe may not be able to pass on that trait to its offspring. And that means no evolution. So let's get back to this idea of accurate replication in a little more detail. And if you think about it, accurate self-replication is a property solely of life. In fact, it's a property solely of living cells. Nothing in the non-biological world is capable of self-replication. That sounds extreme, but let's take a look. Let's say you see a house that you really like, and you want to build a replica of it, because you want the same house. You could do that. You could hire a contractor, a few contractors, and you could replicate everything about the house, the walls, the ceilings, the electrical system, the plumbing system. And let's say you like the house so much that you even like what's inside it, the furniture, the books, the paintings, everything that's in the house. So you want to get a complete, accurate replica of every part of this house. Again, it's possible to do that. But one thing you can never do is find a house that will replicate itself. Okay, now people talk about self-replicating factories, they talk about self-replicating robots. So far we don't have them. They may be theoretically possible, but they also may not be. Because one of the things you'd have to do if you were a house that was self-replicating is you'd have to find all the materials you need and bring them in so that you could use them. That's pretty tricky. On the other hand, when we look at biological reproduction, this is a cell, we find that the replication, this is a cell that has divided in two, is incredibly accurate. It's accurate to 99.9999%. What that means, all the contents of the cell are accurately replicated. How does that happen? I mean, we're talking about thousands, hundreds of thousands of enzyme and protein molecules, membranes, organelles, so many constituents in a cell, millions times more than what you have in a house. Well, the first thing that comes to mind is this incredibly high level of accuracy in biological self-replication. It couldn't have just occurred. And in the breakout session, I'm going to talk about in much more detail about why it couldn't have occurred spontaneously. I'm going to talk about the actual way that this happens using the genetic code and protein synthesis and several other biochemical systems. And normally when we look at something really complex in biology, what we say is, well, it evolved over time. But you can't have evolution without this self-replication. Okay, as I just said, accurate self-replication is required for evolution. So evolution cannot be required for accurate self-replication. And so what we end up with is a circular reasoning fallacy. And here are the two statements I just made. Both, the chicken needs the egg and the egg needs the chicken. And this is absolutely true in this particular case. Now, one part of this I'm going to talk a little bit about only one part here, which is the coded information in DNA. Again, I will expand on this in the breakout. And that is related to the genetic code, which really is a code, by the way. This is a genetic code. You can find it easily. What you see are letters, T, C, A, and G. They stand for the 4 nucleotides in DNA. Again, this will be expanded on in the breakout. And you see every possible set of these 4 letters, and since they're grouped in groups of 3, there are 64 possibilities. And most of them code for specific amino acids, which are the other 3 letters in bold. The genetic code is an example of abstract symbolic information. Now, if anyone feels faint at seeing this chemistry on here, just take a deep breath, look away. It'll be over soon. I'm not going to have any more of this, but I can't resist. What you see on the left is a codon. It's, and again, more detail later, it's a tiny section of DNA, and it is 3 bases, one after the other. The one on the top in orange is adenine, and then the green is cytosine, and the yellow is thymidine. And that codon, that little 3-base sequence of the DNA, means something. It means put this molecule, which is threonine, it's an amino acid, put that threonine next, wherever the right position is, in the protein that you're making. Now, there's no connection between threonine and this codon. There's no chemical connection between them. So that's why this is abstract symbolic information. It's very much like the word tree, whether it's spoken or written, has no connection to the actual plant. Okay, We use it because that's what language is. Language is abstract symbolic information. Now here's two quotes from the two main standard textbooks in molecular biology that's used in every graduate school. Lewin in Genes says, the genetic code is deciphered by a complex apparatus that interprets the nucleic acid sequence. Notice the word interprets. You may remember that Stephen Woodford denies that anything is interpreted incorrectly. In the molecular biology, The Cell by Alberts et al., the conversion of the information in the messenger RNA represents a translation of the information into another language that uses quite different symbols. Now, I've actually met Bruce Alberts. He is not at all a theist, I can testify. And I don't know about Lewin, but generally, this is not controversial in the world of science. I still don't know where this crazy idea that the genetic code is not a real code came from, but I'm trying to find out. So what natural processes produce abstract symbolic information? None. All the abstract symbolic information we know of is ours, okay? And I mean, we are natural beings, but other than that, nothing else produces this kind of information. Now, I talked a little bit about the genetic code, but there are many complex biochemical processes that are required for accurate inheritance, for accurate self-replication. One is the replication of the DNA. One is the protein synthesis, according to the genetic code, and I will, in the breakout, I have some animated videos that kind of I think will be impressive. There are error correction systems all over the place. In DNA, in protein synthesis, there's a huge amount of error correction. And genes are regulated. But none of these complex biochemical systems, all of which have to be in place in order for evolution to work, we don't know the origins of any of them. The first cell that we understand, which is LUCA, the last universal common ancestor, has all of these systems already in place, and we don't know where they came from. So it doesn't really matter about evolution. It's not an important argument, because evolution is not relevant to any of this. So you can hold to evolution, you can deny evolution, it doesn't matter. The argument for God from biology has to do with origins. The origins of biology, the origin of evolution, in fact. So if it's true that evolution cannot account for the design of the earliest life, what can? Well, what's generally proposed is a different kind of evolution, not Darwinian evolution, not natural selection, but something called chemical evolution. And I have to tell you that just before this meeting started, I actually met with James Tour outside, and we talked about this, and he confirmed what I thought is that chemical evolution is a very recent term that doesn't have much of a meaning. What it really relates to is that things can happen because simply due to chemical properties of various molecules, their stability, their whether they get hydrolyzed, whether they interact with other compounds or not, it's very, very weak. And there are many people studying this, but they're not getting very far. It could be a lucky accident, that's out of the question. Nobody believes that, nobody even suggests it. It could have come from outer space, which doesn't answer anything, because it came from Mars, how did Mars get it, or wherever? And the most common answer is, we don't know, but we'll find out someday. I call that future science of the gaps. How many times have you heard an atheist say, well, we don't know, but science has always answered all questions and it'll answer that one also. And finally, the one I believe is that there is a divine designer. I don't use intelligent design because this is way beyond intelligence. None of us could do what God did in creating these biochemical systems. So I would say that if life began as a series of complex chemical reactions that, quote, eventually evolved into a living cell, and you hear that all the time, that statement is simply fallacious. It can't happen for reasons that I discussed. So the origin of life must involve something in addition to natural chemical reactions in order to allow for the origin of evolution. I would like to propose, and I will again expand on this also in the breakout, that perhaps one of those somethings, there may be many, is the idea of teleology, purpose. Is there any evidence for teleology in biological evolution? Interestingly enough, many biologists, including non-theists, like Dennis Noble, who's a very famous biologist, is coming to that conclusion. I'll read these two quotes. Organisms and population of organisms do have identifiable and testable goals. The targeting of variation and the preservation of existing functionality ensure that evolution is not entirely blind. And that last sentence I will unpack again in the breakout. And then quoting this other character, the solution to the problem of converting nucleic acid chemistry into protein chemistry may be the fundamental root of inherent teleology in living organisms. So here's a redesign of that credo. The design of life, this is what I believe, comes from a designer, a coder, a reasoner. And so I would like to redo Dawkins' credo and say that this is what's true. The universe that we observe has precisely the properties, including life, that we should expect if there is at bottom a grand design, a purpose, such as the existence of life that can worship its creator, good and evil, and all that is needed to justify belief in the presence of God. Thank you. John. Oh, I may have finished too early. Cameron, are you here?
I'm here.
Okay. I told you it wouldn't go too long.
That was way too fast.
Yeah.
I was
See, Cameron was worried because I had so many slides, but what he didn't realize is that scientists go very fast over slides, unlike philosophers.
Okay, so we're gonna do some questions, and let's go ahead and begin. If you've got a question for Cy, raise your hand, I'll come around to you. Do make sure that it's one sentence long. I'll be holding the microphone. Okay, I saw a hand over here, but I'll come back over here first.
Oh, by the way, I should say thank you for getting up so early today. I didn't expect anyone here.
Great talk, Cy. My question is, you said earlier there was accurate inheritance is an issue, but you do believe that evolution kind of created what we see. So how if accurate inheritance doesn't really happen, then how do we get what we see? Or maybe I missed a piece of that puzzle.
No, you're absolutely right. It's a little bit like the Big Bang. We can't go back before the Big Bang and figure out what happened scientifically. Okay, we don't know. There's no way to know. Luca is like the Big Bang. From Luca, where you have all of these complex systems, evolution is possible. And evolution can, theoretically, produce everything else that we see. I would say with the exception of some human qualities, but it certainly can produce, bacteria, single-celled organisms, etc., through time, through evolution, through natural selection. But we can't go back before that and say what was before Luca because we don't have evolution before Luca. We can't because it doesn't have those systems. Okay.
Over here, Cy.
Right.
This side to your right. There you go.
Dr. Garte, you explained that, natural selection and mutation change organisms. That's changes to structures that are already there. But why should I accept the idea that those processes can build structures from the ground up?
Yeah, that's a very good question. And many people, as you know, is that Rebecca? I can't quite see. Okay, hi. Many people have questioned that. And there's some good reasons to question that, especially in certain circumstances. I would say that in some cases, it's fairly clear what happened. There are some very complex mutations that do give, you can trace the mutation, you can find out what the phenotypic consequence is, and it is an improvement or a building up of stuff. But that's not always the case. So it's still a work in progress, basically. There are still new ideas about evolution that are always coming out. And the interesting thing to me is that many of those new ideas, it actually has a name called the extended evolutionary synthesis. Many of the ideas in there, I feel, point towards a theistic answer, one way or the other. When I proposed teleology be brought back into biology, teleology is very much related to the idea of whose purpose is it, okay? It's God's purpose. So I am hoping that as we progress scientifically, that we will find more and more scientific answers, like Dennis Noble. He's not a theist. That just as happened in physics when people said, well, the universe had a beginning, okay? And a lot of atheists didn't like that. But it's true. And I think we're at the point in biology where the more truth we find, the more we're going to find pointers to God. And your question raises an area where that may very well be true.
So I've got a question about how evolution is supposed to work. As I understand it, when there's two animals that produce a living organism that can breed and produce again, so a fertile offspring, and then from one species to the next species, crossbreeding cannot produce a fertile offspring.
Right.
So a species jump would be producing a fertile offspring that can breed and reproduce in the next species over.
Yeah.
So I should think even in fruit flies, have we ever seen a single species jump?
Actually, we've seen jumps, but rarely in species, because the way evolution actually works is you don't go from one species to a different one. What you end up is with one species that, in most cases, has 2 or 3 populations that separate from each other, so they can't interbreed anymore. So, for example, the common ancestor of lions and tigers was something else. It wasn't a lion, it wasn't a tiger, it was some other kind of cat. And that cat ended up in 2 populations, which then slowly accumulated microevolutionary changes so that lions started looking very different than tigers. Now, I should say, by the way, this model is accepted by Answers in Genesis. Okay, they have a great model for microevolution, and the only difference between creationists at Answers in Genesis and evolutionary creationists is that what we say is that microevolution is actually what happens all the time. But if you keep going, you end up with what looks like macroevolution. You never have, I once debated Kent Hovind, and he said, a pineapple can't turn into an oak tree. And I said, right. And, you know, not only that, a goat cannot turn into a sheep. Goats only produce goats, you know, et cetera. But some goats are different than other goats. And if you separate the populations, eventually some goat may start looking like some other species. So, you know, that's sort of a general overview of evolution. And I have a whole video called What Evolution Is Not, because a lot of folks mistake what it's actually saying. But that was a very good question. Thank you.
I see a question all the way in the back, so I'm going to head back there. Bear with me.
So how some people would think about genetic mutation is that, you know, there's an organism and their genetic code is the way it is, and then the mutation.
Let me just stop you right there for 1 second, if I may.
Yeah.
There's a big confusion between the word genetic code and the genetic sequence. We all have the same genetic code. We, oak trees, bacteria, fish, there's only one genetic code. But we all have different sequences, and that's what makes us different. Okay, go ahead.
Thank you for the clarification. So how people might think of it is there's the sequence, and then there's some malformity in the sequence as a result of the mutation. So one might think that the result of that mutation is that there's a deficiency within the next organism.
Right.
So then you might think that that organism may not have as much of a potential for survival based on that mutation.
Right.
So I was wondering, I think there's different mutations, so I was wondering if you could clear that thinking up.
Yeah, so the vast majority of mutations are not good for you. You're suffering a mutation right now as we speak somewhere in your body. And probably it's neutral. It's not going to have any effect. If it's not neutral, it's probably not very good. And so that cell will die. In very, very rare cases, it's really bad and can cause, for example, a tumor. But it's true that the vast majority of mutations are not beneficial. However, if you do the math, you can find out that even if you have 1 in a million mutations, which are good, which are beneficial, that will eventually spread through the population. So there's no dispute about the idea that most mutations are harmful. But this is not computer code. I know a lot of software folks say this. They say, well, you know, if I randomly change a piece of software, the program dies. Yeah, but that ain't life. Sorry. Life is different. And if you randomly change, you know, a base in the DNA, the program doesn't die. The cell might die, but the organism may not. I mean, will not. So a very, very rare beneficial mutation can, in fact, spread.
Hi, I've worked with Dr. Tor, and so thank you for meeting with him. That was really cool to hear that. So I'm from IT. I'm from the IT world. You're speaking about software, so all of this kind of rings home with me. Engineers in the IT world, with intent, we create what's called data risk management. So we want to protect against data loss. One example would be RAID 1, which is a redundant array of independent disks where you have 2 hard drives. So if one of the drive fails, you can still operate.
Right.
It's not necessary for the function of the code, but it's necessary for something else for data risk management.
Right.
We have that same thing with DNA and its double helix.
Yes, we do.
So what is the origin of the data risk management characteristics that we find in DNA?
That is a fantastic question, and we don't know. Okay. It's possible that evolution had something to do with it, but there's some reasons, just as I said, for many other things, that's a little bit of a stretch. But the amount of redundancy and error correction and all the things that you're familiar with that exists in biology is astounding. Redundancy in particular it's a whole field of research, and you know, sometimes it seems clear that this was useful to the cell, so maybe it evolved, but sometimes that's not the case, and we don't really know the origins. Thanks for that, because that's something I didn't include.
All right, so we've got about another 5 minutes or so, but I wanted to let everyone know we're about to, after this, we're going to do breakouts. I'm trying to flip this over. On your handout that you got, if you don't have one, the breakouts are going to start at 9 o'clock. Dr. Braxton Hunter, his breakout is Evangelistic Apologetics. Dr. Josh Rasmussen, You Are More Than Material. Dr. Liz Jackson, Philosophy and Formal Education. Cy Garte, he's going to be sort of extending his talk here, Biological Design, Evolution, Abiogenesis, and God. Then Trent Horn will be presenting on the argument from motion. I want to go ahead and release the other speakers to go ahead and go upstairs and get set up now so that we can be ready. And Cy, once this is over, we'll go up there together and get it. But I just wanted to let you know that's what's going to happen. We're going to end in about 5 minutes, and then we'll get ready for the breakouts, and then meet back here at 10 for the main session from Dr. Braxton Hunter. All right, so let's get to the next question.
Good morning. Cy, can you please spend another minute or so elaborating on what I think you said where chemical evolution is impossible?
Yeah, thanks for that. I'm actually doing a little work on that myself, theoretical work, and it's an incredibly difficult problem. I'm going to show in the breakout quotes from 3 of the leading scientists who are working on the field, and they're very pessimistic quotes. And these are the people who are the leaders. The problem is you've got to do things like make RNA and make proteins and have all these polymers going with almost no tools, because you have to depend on the rules of chemistry, which are very harsh. And again, I'll quote Jim Tour. I mean, there's more hydrolysis than there is synthesis in chemistry. What happens when you start making something is it falls apart. Okay, there's no, I mean, Richard Dawkins talked about natural selection as the crane that lifts, things from one thing to another. And it's true, natural selection can be very powerful. We don't have that in chemical evolution. We just have to hope that the, concentrations of the right chemicals are in the right place at the right time, and that they have the right reactivities to react and do stuff. And they don't. Uh-oh.
No, it's not. All right, I just want to know, what is your currently favorite mechanism that goes beyond the modern synthesis?
Favorite mechanism for what?
Favorite mechanism proposed for evolutionary complexity, phenotypic complexity, that goes beyond the modern synthesis stuff discussed.
Yeah, I don't know yet, Tim. I think an honest biologist, Christian or not, has to say, I don't know, a lot. It's one of those fields where the more we learn, the more questions come out, which, by the way, I think is another strong argument for God, but I'm not a philosopher, so I won't say it. Why is that true? I mean, why is it true that so many answers that we find simply lead to 10 more questions? And that's what we're finding now in biology. Just as physicists in the end of the 19th century thought physics was done, right? They had everything except this little question about light. Biologists for a long time thought it was all done. We had everything. We had the genetic code, we have evolution. Now, the more we learn, the less we know. So I don't have a favorite idea. I like some of the ideas in the extended evolutionary synthesis, but we're a long way to go.
So David Hume's objection to the design argument was that plausibly nature could just be run by a bunch of self-organizing principles, impersonal laws and forces and that sort of stuff, and that you don't really need to posit a divine mind. What's your response to Hume?
Well, not only I'm not a philosopher, but it's kind of hard to answer people who live that far back when we're talking about modern science, but on the other hand, there is a good point here about natural laws. And many people in the ID movement have said that There are natural laws we don't know yet, and this also somewhat answers Tim's question. There are natural laws that we're not familiar with about how biology works. I'll give you one example. There's a great biologist named Simon Conway Morris, an English biologist who has been studying evolution early on. And he has come to the conclusion, which is absolutely rock solid with evidence, that there are constraints on evolution and that there are directions for evolution. You keep getting the same kind of wings. No, there are no jet flying animals. Why not? You could have a jet. No, there aren't. There are specific ways that animals fly, and they flap their wings, okay? The eye has appeared many times in very different lineages. So there are laws, there are specific directions and constraints. You can't get anything, and you do get the same thing over and over again. So yes, I think that part is correct. And you know, evolution is not the law. It may be one of the laws, but it doesn't tell us everything.
All right, I think that's going to do it for us today. So if you have more questions, go check out his breakout. He's going to go ahead there now. So one more time, let's give it up for Cy.